Okay, good morning. I don't know if you can you hear my voice? Okay, so I think all of you understand that now the number of new confirmed case in Hong Kong is keep increasing to the highest now. So that I do hope that all of you can really follow the advice we mentioned while in our the guest lecture. So that's still I can see one of important thing. I hope all of you then can keep you healthy and then to overcome this kind of difficult period. So that before we talk about our lecture, I still want to remind you about this important this kind of issue. I do say so that I do see we have a lot more people will get this kind of virus infection, and then of course a lot more people would die. Do you say now at least we have reached 500 people die in this fifth wave of COVID-19. So that remind you to follow at least the minimum this kind of way. You are healthy, and of course I don't know. Do you have any question for this kind of do you have any question for this issue, COVID-19? Or you already got, at least I can see we have about 100 people, USC people got this infection. And yesterday, even our UG student in our MAE department all got this kind of infection. So I can see that a lot more people will get this infection. So of course, although internationally we know that some country they for this kind of mutant virus, right, Omicron, they think it looks like normal, but at least in Hong Kong, some people become got very serious this kind of symptom. So this is something I still want to let you know that you be very careful. Of course, another important thing I also want to remind you, right? So that this kind of COVID-19 virus, from our point of view, right? Building immune is what? It's bioaerosol. It's very, very tiny. This suspended, this kind of virus particle is suspending air. That means this kind of virus can spread inside the building, right? It's not just you do say so that something. Although in at least 1 or 2 years ago, when we look at this kind of virus, most likely is you maintain the kind of social contact or social distance. But from all this kind of infection in Hong Kong, it's clear it's not only this kind of no, you have a close contact. Even you didn't contact those people who got virus, you still can get virus. Do you understand? So this is one of a big issue, right? So that and of course that's something. I don't know. Do you have any question about this problem? Okay, this is something still I can see is important for all of you to make sure you stay healthy, and then of course if possible, even in your apartment or a student hall, I also remind you to do this kind of exercise, right? So that's something also quite important. Once you do enough exercise, you keep your immune system more robust, right? To fight this kind of virus infection. So that's another important thing I need to remind you. Okay. Do you have any question about this issue? COVID-19? So that at least I can see we are going to have a lot more people got this kind of COVID-19 virus. Okay. If not, then I think we need to go back to our lecture. So that last time we keep talk about this kind of building system, and then of course we mentioned about a series of mechanical design, and also fire detection, and there's a series of in terms of engineering. You say, okay, so the building is assistant engineering, right? Require have understanding about this kind of mechanical engineering, right? Mechanical design, water supply system, HVAC, electricity, lighting, fire protection, elevator. So that's something we just briefly mentioned. Of course, we also show you there's one thing. Unfortunately, as I mentioned, shock load, right? Shock load is unfortunately is not only to 911. If you look at the recent news about the war, right, in Ukraine, right, the Russian this war, so that you may want to watch this kind of real evidence about this kind of shock load, huh? So that this is not unfortunately this is a real issue. If you look at this kind of real, let me show you this kind of video. Then you see this is unfortunately this is a very bad situation. But it's a real happened several days ago, right? In this the capital of Ukraine, Kiev. So that's the important question. Why?
The missile slammed into an apartment block in the south of the Ukrainian capital, Kiev. The attack's evidence, say the Ukrainian authorities, of Russia's willingness to hit civilian targets.
So
we managed to escape. We were in kitchen. We were lucky. It was a direct hit in a living
so this
room.
is a shock load.
Had their legs broken.
So that still it's an important issue, right? For tall building, and then so that
Ukraine's president had warned of a difficult night.
For this tall building, so how we can our mechanical engineer, mechanical design can now be useful for this kind of shock load, huh? This is something is not funny, right? It's a very serious issue. So that of course, if you want to have a building who can be resistant to the shock load, so what's the issue, huh? What do you think? How can we come up with a design the building, huh? To be more this kind of shock resistant to this kind of shock load. What do you think? This is a quite difficult issue. Any idea? How can you try to have better design of the building who has a much mechanical have more higher mechanical strength to deal with this kind of shock load? Do you any idea? Huh? Some cities and increased resistance to high temperature. Build underground. Well, for some very difficult wall, right? Of course, people may think about, yeah, you're right. So if you have a building underground, then the missile cannot hit you. That's the thing. That of course that's something unfortunately this is something difficult, right? So that of course if you want a building to have more resistant, right, to this kind of shock load, then of course most likely it will be more expensive, right? And then so that you need to think about how to have this kind of maybe using some material who has a higher mechanical strength. Do you understand? So that's something, or maybe you can use some of the new type of material, new nanomaterial which have more this kind of mechanical strength. Do you understand? So this is something I can see is a difficult issue, right? So that the engineer have to find a balance between mechanical strength and the cost. If you want to increase this kind of mechanical strength to be more reliable, and then so that one issue is you may think about actually most likely it will be more expensive. So this is something quite difficult. Why? So that to deal with the real engineering. Yeah. Of course, so that is something difficult and important issue now. Why? So yeah. Okay. Anyway, we just quickly mention here, and then of course we also talk about the issue about foundation, right? And then also the maintenance issues. So that similar to the human, the building may get sick, right? You will get virus or some get flu, and then so that the building will also get the problem, and then due to the corrosion, abrasion, connection fatigue, and impact. So that in this case, it's important to think about how we can try to do this kind of maintenance, and then also, of course, there's a lot more issue, right? So this kind of as I show you that in general, we have a multiple engineering design issue for the building, right? In terms of water issue, water leakage, water infiltration, air infiltration, and thermal. This is thermal problem, thermal expansion and contraction. Once you have a very high temperature or very low temperature, and this kind of thermal cycling and then may cause some problem, the stress problem, thermal stress problem on the building, mechanical structural building. Right? Of course, you have additional heat transfer, moisture, some building, and other things. So that's a lot more issue, right? So that last time we also briefly mentioned about all this kind of issue, right? So that before the building can the degradation of a building due to this kind of multiple problem, right? So that's thing, and then of course in general, water is not good for the building, huh? Water may cause some big problem, right? So that gravity slope zone, kinetic wind driven rain, surface tension, capillary action, air content, and then pressure drop. Okay, so there's a lot more issue here. So here I show you the typical how the water can have impact now in the building. So that you can see if you first is like this kind of gravity, the rain, okay, kinetic energy, surface tension, capillary action, air current, pressure difference. So all this can cause some damage and degradation of the building. So that so what do you think? How engineer can deal with this kind of water issue? Huh? How can we do? Sometimes we do what? Coating. What? Water-proof coating, so that make sure that it can be more water resistant. So I think one of very common issue, we can do some coating, some special coating to improve this kind of waterproof performance. Right? Do you say? So this is one of, I think, one of very common thing people will try to do the thing. Of course, actually, as I told you, I'm involved in this big Hong Kong CRC, this 5-year big research center project, funded $300 million grant. So we do know that there's some engineering issue, huh? There's way to do some coating, right? So definitely there's some special coating be used in this kind of to improve this kind of water resistance for the building. So that in China, there's one big company who actually have been doing very good business, right? In China for this kind of different kind of coating or special material. So that maybe I can give you this kind of some reference, right? So at least we try to actually work with this kind of company there's one company actually is public company in mainland China. Okay, so that they really has a big business in this kind of waterproof, this kind of coating. So that I just tell you that there's some interesting seeing that so that actually all this kind of building engineering I can see is important. Why is important for real business. Here, let me show you about this Beijing Oriental Hong. Don't actually this is one of a big company. They really work on this kind of coating for the building to as waterproof. You say so. I just tell you that this is a public company in mainland China, so that they have a star. So that is almost the biggest company in mainland China. They can really do this kind of very good business. So that of course, what's the issue of this kind of thing? Actually, we have a team. We have a team. Hong Kong CRC, the art actually work a team to work with this company. So one of the issue is of coating, right? So actually, this coating is remain what manpower to do the coating. So that so how can we do more automation to do this automatic coating about this kind of material, waterproof material, something so that we have a full time this kind of team to work on this kind of automation. How you can make this kind of new kind of machine so do automatic coating of this kind of material. Why? So that I just told you this is this company is almost biggest company in China to do this kind of waterproof business, and so that and it's a very big company. I would say. Let me show you. They gave you a link, and then maybe at least I know that we have a team to work with this company to make this kind of automation system, right, to make it more efficient, right? So I'm sorry, this is only, I don't know if an English website, but at least this is one of there's also it's one of I think biggest company in China to do this kind of coating for waterproof the coating. So that and how, again, the key issue is now once a good material and how it can be low cost and the more efficient to the coating, right? To set the manpower. This is one of important issues. So that so we have again we have a team to work with this company, the biggest company in China to make this kind of machine, right? To do automated coating. Yeah, I just tell you, many of this actually is quite important, right? Yeah, and then of course air infiltration is another issue, right? So that especially we have if those kind of office building, we have this kind of central HVAC system. In Hong Kong, we only have an air conditioning system, so that in this case, most likely it's an air is supplied by central air conditioning system. So that in this case, we may need to make sure that we have minimize this kind of leakage, air leakage, so that otherwise, if you don't, if you have this kind of air leak, a big air leakage problem, and what happened? Consume a lot of energy. Do you understand? So that thing is a big issue. Of course, there's some standard. For example, ASTM E283 standard minimize this kind of the flow rate of this kind of air. Now leakage from indoor to outdoor. So this is something quite important. Why? That's why it's an industry standard, ASTM standard. Yeah, and of course, there's additional loading effect. Once you have a wind loading, like in Hong Kong, typhoon, seismic loading, and then how we can really deal with this kind of engineering issue, right? And of course, another heat, right? This kind of heat transfer, right? Once you have a very high temperature, low temperature, then they can cause some thermal expansion, contraction, right? And then, of course, heat transfer also affect this kind of energy efficiency of HVAC, heating, ventilation, and air conditioning system. So that this that's why we may need to think about how to come with a new material, a better material, have a U value. U value is related to this kind of thermal conductivity of this kind of material, so that to make sure that actually make sure they have usually why you want to have what high this kind of low thermal conductivity, so that less this kind of heat transfer will not go through the wall, right? So that you have a good thermal insulation. So that this is something quite important, right? To have more energy efficient design. You understand? If a very hot temperature, then you have a lot of this kind of high temperature and cold. This kind of sometimes you can heat the wall, so that then if you better this kind of thermal resistance, and then so you can minimize this kind of heat transfer through the wall, right? And this is something quite important for energy efficient design of the building. Yeah, you can see. Oh, there's another thing is about the window or glass, right? So traditional, if you use a conventional window, so then you see typical maybe 100% of solar radiation, so energy, well, maybe many energy go through pass through this kind of a wall or glass, right? And then so that there's additional reflection radiation, so that if you had come with heat absorbing glass over some additional double like a panel, okay, so that two kind of this design, and that's an additional design. For example, yeah, not only one, you have two layer of this kind of glass, and then in this case in between there may be some additional air in between. So in this case, you can have a little bit better design and more energy efficient. So in this case, we pack with some air inside, and then these two glass, and glass, so that there's a much better energy efficient this kind of window, why or glass to design, so they can be more energy efficient. Of course, there's another family is what? Smart window. Actually, 7 years ago, I have a project, UST MIT project. How come with this kind of new smart window or smart building? Why? With a lot more sensor, with this kind of control or AI control this kind of actuator. Actuator mean maybe control air conditioning system, control this kind of this kind of so every office and also this kind of classroom in UST with some kind of central air conditioning system, right? So that in this case, how can we have more intelligent this kind of control about HVAC, smart air conditioning system, and those control thing, right? That's important thing. So that here I show you this kind of basic thing, but there's always additional way to do on this kind of glass design for smart window, right? So that actually I will give you additional more information about this kind of additional smart sensor, right? How the new type of sensor and actuator or maybe smart window be useful, right? For this kind of building, right? Energy efficient building and green building, right? Of course, there's another issue about moisture condensation, especially in Hong Kong. We have in between summer and winter, in the spring, this kind of season, so that we have some special season become very humidity super high, maybe 99%, 100%. Wow. And then there's some kind of condensation in I think typically probably in April, May, or some special season, so that we have a lot of this kind of problem, condensation of this kind of moisture. Why? Because too humid, and then so that this kind of moisture will do some condensation on this kind of floor, or depend of the wall. In this case, it can cause some big problem. Sometimes they can cause it kind of get molded. Sometimes you have seen. So this is something typical. This kind of condensation of this water vapor, right, will be a function of temperature and relative humidity. So this is something, but it's more than that. So that it's actually about several months ago, I just see that there's a one international student competition. Actually, they call ICANN. So I remember this one team from Switzerland. They tried to come with they kind of interesting sensor, multi-sensor module to minimize this kind of moisture monitoring system. So that this condensation can really very bad for the building. It can cause some degradation, and some of this one, if too much this kind of condensation, and cause what get moldy, and then it's not very good. And of course there's an additional thing about ceiling and floor. So that typically ceiling, we want to have some good design, and what's the typical issue is we may need to think about how this ceiling have a good mechanical design, and also we have a good this kind of maybe additional waterproof, right? And then waterproof, and also maybe this kind of design have additional acoustic. That means we can try to be more minimize this kind of noise issue. So there's a lot more issue in terms of practical engineering. So not only a pure mechanical design issue, but also to deal with the other thing. Typically, there's another important thing for every building is water. So every building has a water supply system, also wastewater. This kind of a system. So that in this case, so that the water system is important, but also it can also cause some problem, right? So that in Hong Kong, we have a very unique water system. I don't know if you have some idea. Hong Kong has a interesting system for water supply, especially for this kind of a toilet or lavatory. I don't know if you have any idea, because I think 50 years ago, Hong Kong don't have enough water. So that we have a student mentioned about, because we don't have enough fresh water. So that the Hong Kong government actually tried to build this kind of unique water supply system for this kind of flush kind of toilet, right, to save this kind of fresh water. So this is somehow is a little bit unique, I would say. So that this is something not every this kind of city will use seawater, right, to wash this kind of toilet. But Hong Kong suffer this kind of shortage of fresh water supply, I think in 1950-60, and so that eventually the government provide additional infrastructure so that we use this kind of seawater, right? That's not only fresh water but also seawater. So we have a dual water supply system, right? So that this is, I think, still quite unique for Hong Kong. And of course, there's another issue, right? So for all the water system, and then we need what has a meter, right? How you can measure the kind of to monitor about the water supply, right? And then piping, right? So that the piping may be also issue, right? Some of this piping may be too old and then cause some problem, right? Degradation, and then some pipe, if you're not using the right material, it can cause some additional contamination. I still remember several years ago, Hong Kong do have problem about those kind of material used for water supply. If you use the wrong material, and then there may be some contamination, right, of this kind of fresh water supply. And hot water heater, there's a lot more issue, right? So if you have this kind of hot water supply, then you need to think about how to make sure have a additional thermal insulation of this kind of piping, right? And then also drainage system. Of course, remove the black water from toilet. The special terminology used in building engineering. Black water for very dirty water to wash the toilet, and gray water actually it relate to the those water from the bathroom, shower, tub, and washer. Okay, and then of course piping for drainage is another quite important issue. Right, so you need to make sure that you have used right material, right way to do this kind of engineering and minimize this kind of leakage. And of course, finally, is a appliance. Right, some appliance may need this kind of additional water, and for the drainage system, so that one of the issue is what, as I mentioned, as a student mentioned, right? So that we try to use water to flush, clean up something, toilet, clean up this thing, and then some of the issue is this dirty water, or they don't want dirty water, black water. So that in this case, in order to minimize the problem of this kind of drainage system, so there's a special kind of P-trap. P-trap, this is called some special kind of P-trap system. It's some special design to what? To prevent this kind of sewer gas from rising up through the drain and toilet in the building. Because if you don't have this design, and then sometimes those kind of dirty water or black water can cause some become very smelly, so that then it's not good. So this is something I think important, right, in terms of practical engineering, right? So that it's not just we have this kind of water supply, right, fresh water and this water to get rid of this kind of dirty water, but how we can minimize additional issue, right? For example, here I just show you this additional video for you to look at this kind of what is the P-trap. So that if you look at this simple like image, right, in our lecture note, is maybe not clear enough. Let me show you about this kind of video. Usually simple video can easily explain about that thing.
If you notice a lot of extra piping under your sink, then you're looking at the P-trap. P-traps are named after their shape. They use a small bend in the pipe to trap water, creating a seal. This trap seal prevents sewer gases and odors from leaking into your home. As water drains through the P-trap, air is pulled from an outside vent to equalize the pressure. Now, if the vent is blocked by snow, ice, or debris, then the trap seal could be sucked out with the draining water. When this happens, you might hear a gurgling sound as air is pulled through the sink drain, and you might start to smell sewage coming out of that sink. Without access to outside air, the vacuum in the system might pull air from another plumbing fixture. For example, flushing the toilet could pull air from the sink, removing the water from the trap. So if you smell sewage out of the sink drain after flushing, this could be a sign of a larger ventilation issue. S-traps are similar to P-traps, but are no longer installed in homes because they have the potential to lose the trap seal. If enough water travels through an S-trap, it will create a continuous channel through the pipe and will siphon the water out of the trap. Fortunately, an S-trap can be retrofitted into a P-trap by adding a trap arm with proper access to an air vent. Additionally, a buildup of waste can also create problems. Strands of fabric and hair along the pipe can cause water to slowly leak out of the trap through capillary action. This is why it's important to keep the P-trap clear of debris. Hopefully, this has given you a better understanding of how a P-trap works.
Okay, so this is just give I do think this short video will be quite important, useful for you to understand this kind of this kind of P-track design. Do you understand? If you look at only this kind of picture, and then so it's much more difficult to understand how this P-track work, right? Okay, so that okay, and then of course oh, plumbing. That's another important thing, right? So that that means how we can have this kind of a piping system. The pipe used in a building actually turns out to be much more complicated than those what you think, right? So that typically especially in those kind of like building, office building or building, so that you see typically they have come with a different color system for different pipes. Okay, for example, this orange pipe, steam, and then heat. A pipe maybe yellow, water blue, sewage brown or black water. Fire protection is red. No, so that that's at least this is a typical five type of a piping system in a building, right? And then use this kind of color code to prevent this kind of making some mistake or something. So this is something in reality, right? So that the piping system, now water system in the building can be much more complicated. Yeah, and then of course another important thing is HVAC. Of course, we have additional chapter focus on this thing in Hong Kong. Most likely we have only AC. We don't have this, but for northern part of China or Russia or United States in some part, so that some in the winter it may too cold, so that we in general, that's why we have this kind of HVAC, so that heating, ventilation, and cooling. So this is typical thing that you should say that we have this thing, and typically we are using how can we heat the air, make it use a fuel, oil or gas, right? And then sometimes, of course, there's an additional this kind of central system to do this kind of HVAC, do you say? And then of course air conditioning also classified in several different design, so that typically we have this kind of heat exchanger, like to, for example, the air flow over this kind of coil. Coil most likely is in a liquid, right? So in this case, then we have some heat exchanger. Maybe I should show you some simple explanation. Basically, is most likely is you have a certain kind of heat exchanger, so that you hear coil. That means we most likely we have this kind of coil, right? That means you have some chill water, right? You have this kind of, sometimes they could chill water. Okay, and then so that it goes through this coil, and then you have additional separate air flow. Okay, goes through, and then so in this case, then you have this kind of heat exchange between the cold water and then the air, so it can cool down the air temperature, air flow temperature. This is quite important, right? So like in like a typical building, like in UST, so we do have this kind of thing called system, this kind of chemical system, so that do that. So that means electric fan and then coil, and with, so that in this case, and then we can try to do the kind of heat change and then cool this kind of air into low temperature for air conditioning system. This is a quite common. As I told you, every office and classroom in our our UST this kind of building, we have this kind of Fenco system, so that in this case, of course, this kind of chilled water supplied by central this kind of system, air conditioning system. So that this is one of quite important. You may want to understand about a fan coil unit, right? So that this is a typical thing in a building. Okay, so that the fan coil unit for this I show you what's a typical this kind of a way. Let me show you a simple video, so then you can have some basic understanding about this thing. Again, in every offices and classroom inside our UST building, we do have this kind of fan coil unit. Let me show you this very basic video so that you can understand. This is it every office, no, and also the classroom.
Hey there guys, Paul here from theengineeringmindset.com. In this
Every
video, we are going to be looking
offices
at
and classrooms
FCUs.
in our UST
FCU
building
stands for fan coil
unit.
Now, fan coil units are very common in all types of buildings, from offices, bars, canteens, even some homes and maybe apartments will have a fan coil unit in them. Fan coil units are used to condition the local air to suit the temperature requirements of the immediate space. So as you can see in this model here, we've got this space here, and there's a fan coil unit in there with the ductwork going off to feed the various parts. And then on the fan coil unit, we've got these pipes running to it, which are the cooling and heating coils inside, and the air which is being supplied to there is being treated and distributed through these local ductworks to supply the required air. So in this building model here, you can see we've got the main AHU here, and that's supplying fresh air through this main duct all the way along to the rooms. And branches will come off of this and they will feed fresh air into the space. Each space will need a certain amount of fresh air per hour entering into the space. So you'll have a branch coming off and that will feed the fresh air into there. So this fresh air is directed into the inlet of the fan coil unit, and it's usually not connected though. There's a gap in between. There is a reason for that, which we'll look at later. And so that fresh air enters into the box. It gets sucked inside. Here's a fan. We'll have a look inside that shortly. And that air gets heated or cooled and pushed out through these diffusers into the space. Now some of that air will recirculate up through the false ceiling, through those grills we looked at, and into back into this box here, whereas some of the air will be picked up into this return duct, and that will be sucked by a fan here and pushed out of the building. So the fan coil units are located up in the ceiling. So this is a false ceiling in a typical office, and here you can see these diffusers. These are the supply diffusers, so that treated tempered air is being supplied into this office here, where it can circulate there, and all of it gets sent back up through these return grills. If that false ceiling wasn't there, it would look something like this. So we've got a fan coil unit, and we've got these the ductwork which is supplying the air. These are also diffusers. They're just slightly different from the square ones we saw just a second ago. So this fan coil unit is sucking up all the air in this space, and it's passing it across here. There's a fan inside, and it's pushing it across a heating and cooling coil, which treats the air to the right temperature that it's set to for this area, and that air is then pushed out through these ductworks to be supplied out through these diffusers where they're required. So this is the supply duct here, and as you can see, the fresh air is coming in and is entering into the space above this false ceiling here, into the void above there. Now this fresh air enters into the fan coil unit.
Okay, so here and this I give you some one example, right, about the real this kind of engineering in almost every, as I told you, most likely in UST, right? Every building we have this kind of this thing, and a lot of this kind of fan coil unit. We use this one and for to cool sometimes heating and cool, right? It depends on this kind of I think region. So that in Hong Kong, most likely will only have this kind of AC unit. We don't have a heating unit. So that's most likely it's chill water and air. So this is some, but okay. And again, in general, we, in order to have much more energy efficient design of this kind of HVAC system, so that we may need to have additional material, insulation, thermal insulation material. This, I would say, this should be a little bit more precise. I would say it's a thermal insulation, because there's another issue is electrical insulation. So I think maybe I should put down a bit more clear way. It's called thermal insulation. And again, to minimize this heat transfer, right? For between inside the pipe and outside this kind of environment, right? For indoor environment. So this is something, and typically, so that we may use fiberglass, right, as those kind of thermal conductivity and thermal resistance is probably much lower, right? So that and then of course this is something you may see actually if you go to typical this kind of tall building in Hong Kong. I believe probably you can easily see this kind of the pipe now coated with this kind of color, and it's very common. Okay, and then of course we also need to think about electricity and lighting system, right? So that typically, of course, electricity is one of I think basic this kind of supply for every building now, right? So that the electricity goes through this kind of every building through some special kind of, for example, different like power plant, right? Like CLP providing, and then most in Hong Kong is 220 volt, but in the other place like United States is I think in China they are different, right? So that and then of course I think all of you have no problem to understand basic the unit used in this kind of electricity, right? In probably the physics, the volt, right? And then current means ampere unit for measure the electric current, and watt means this energy, right? It's power, right? The volt multiplied by this kind of ampere, the current, if you watt. And then typically, what we try to define this kind of energy for electricity, right, or something is watt hour, right? So that means this watt is energy per unit time, right? So that if you multiply by time, then you become energy. So this is a typical way we try to describe about this kind of energy. Okay, and of course, there's another thing, right? So that lighting is also important for every building, right? So that but energy consumption of lighting can be important issue. So that commercial building may be quite using lighting energy a lot, right? So that in this case, what we should do, Can we come with a smart lighting system, Smart lighting, for example, if you have some proximity sensor, right? If nobody here, then the automatic turn off the light. If someone come, and then so this is something I can see in the near future. We must have much more this kind of smart lighting system, right? Smart lighting, so that of course I don't know if you know that in your smartphone, you do have this kind of interesting proximity sensor as a way to smart control of this kind of LCD display for your smartphone. Actually, I believe this kind of thing is can be quite useful, right? This kind of special type of proximity sensor, right? Let me show you. Now, every smartphone, the new smartphone you have, has this kind of proximity sensor, local proximity sensor, so that you can really low cost proximity sensor, okay, so that to save this kind of energy of this smartphone, so that I can see that if this kind of low cost proximity sensor can be used in the building, so that then I think it's possible. No, you can create this kind of much more energy efficient design, right? And the same thing, of course, for industrial plant, we use much less this kind of energy for lighting. Of course, you may heard about the kind of smart manufacturing plant. What do you think? Some of now modern manufacturing plant, maybe we try to do a lot more automation, or 100% no operation based on machine automation to do mass production. So in this case, maybe we can turn off all the light for this kind of new generation of industrial plant, industrial 4.0 plant, so that we don't need any like a human that can the worker inside this building for mass production. So this can be quite interesting, important. What do you say? How can we come with a smart this kind of building design to save energy? Yeah, and of course there's a lot more. Why? So that the lighting, as I show you, sometimes you may want to think about use what? Solar energy. Why? The lighting from the sun. So that of course in this case you may need to think about the design of the building, right? And then think about this kind of window or some glass, right, panel, so that to let reasonable amount of the solar radiation to enter the building, and then you can really make sure that it can be leverage kind of solar energy and minimize this kind of energy consumption for lighting. Okay, so that typically I think all of you have no problem to understand this kind of electricity bill, right? So that of course the key thing, 1 unit, right, is like kilowatt hour. Okay, so that so typically we use this kind of kilowatt hour as a way to define, right, the energy, electric energy used by this kind of appliance, right, for 1 hour, and then as a consume this kind of 1 kilowatt. So that this is a typical way to categorize this kind of electricity bill. Yeah, of course. What's the issue? For the very tall building, right? So that if we have many user or many this kind of apartment and offices, and then for different company or customer, and then so in this case, then we need to think about additional the kind of meter, right? Electricity, this kind of a meter to make sure we can really try to monitor this kind of consumption of electricity, so that this become also quite important thing. Typically, of course, in Hong Kong we have a CLP. Typically here show you this is typical this kind of how much it charge you about this kind of electricity bill, right? So that of course they usually provide some additional incentive. You see, depends on if you really have a more energy efficient this way to energy saving, and then you can have a little bit cheaper this kind of energy bill, right? Yeah, and of course so there's another incentive now, right? So that you see it most likely, right, they classify the 2 period of time, on peak and off peak. On peak, that means most likely, right, off peak, that means probably in midnight, so that you see 9 p.m. to 9 a.m. in this case, so that they can give you some cheaper this kind of rate, right? So that in this case encourage this thing, because why this is critical? Because sometimes or most of the time, right? So this electricity, that's power plant, the general power most likely is continuous to provide this the electricity output, so that In this case, of course, during the daytime, right, from 9 a.m. to maybe during the work times, 9 to 5 p.m. So that most likely a lot more people use, right? But in off-peak, then they still generate this energy, electricity. So that in this case, if don't consume, sometimes it wastes some energy. Okay, so this is a typical way, right? So that this kind of electricity power plant want to encourage the uses of electricity in the off-peak period. Of course, how can we leverage this kind of off-peak energy? I don't have any idea. So that how can we leverage this kind of off-peak, this kind of off-peak, this kind of period? Huh? What do you think? Very good. One student say Paul Yan, as you mentioned, it's store them. Sometimes you're right. If we have additional this kind of maybe rechargeable battery or something, right, to store this kind of electricity, right, in one apartment in a building, right, and then in this case, if it's some energy storage device, we try to get this energy from the COP, then we can try to get a much cheaper this kind of electricity bill. That's some way, especially for very big company, why they want to save the cost, right? So that in this case, if you have this additional energy storage device, right, for big company with a big this kind of office or manufacturing plant, so this kind of thing do have some incentive to thing. Okay. Finally, we also mentioned about this fire protection. So that well, fire is one of a very critical issue for every building engineering. So that of course, if you look at our UC building, we have this kind of sprinkler in almost every office and classroom. Okay, and then but beyond this spring, you can see there's additional piping, pump, tank, and valve, and other things. So that this is something become, I think, mandatory. Right, most of building code from the government will request this kind of additional this kind of engineering for fire engineering to make sure that this kind of building is safe, right? Yeah. And there's another thing about the elevator of lift, right? So that typically, of course, if you're a very tall building, so that in the case, most likely this will be necessary, right? If you have a 20, 30, or 40 floor or even higher, many floors, so that I guess nobody can really try to now walk through the stairs, right? For the tall building. In this case, so that this kind of elevator or lift would be necessary. Of course, there are different kind of design of this kind of elevator and lift. So typically, of course, you have some car, right, and then powered by some motor, right, and then try to move this kind of car now up and down. So this is a very typical thing. Okay, so here they show you typically you can see you have some cable, right, and then the cable will try to move around this car, and then there's additional machine room, right, and then try to have way to do some control about this car, right? So that with additional thing. But of course, the key issue is, of course, during this kind of how this kind of elevator can be work, right? During this kind of maybe some special emergency, if there's some emergency, some fire, then so that there's much. I think every this kind of elevator manufacturing company, they have some additional way to do this kind of design, right? Make sure that it can save, right, in different kind of emergency condition. So typically, so that they have two kind of deep design hydraulic system. Why? And then, is hydraulic system in this case is a little bit cheaper using this kind of but in this case of course it's a hydraulic system, and then in this case usually it can have I think it can have a larger this kind of power to move around this kind of car for elevator in the coming this kind of, as I show you, we have a lot more this kind of a smart building idea, intelligent building, so that every this kind of thing, then here we have some smart elevator. Why? Smart elevator basically is most likely is a elevator. Now you have some additional connection, connect to the internet, and then provide what most likely you may have some additional sensor, sense this kind of vibration of this kind of elevator to do this kind of predictive maintenance, and with maybe additional wireless this kind of sensor, so that to monitor about the health condition of this kind of elevator. Do you say? So that even now in recent years, still we sometimes see some big problem of this thing. Let me just show you about a typical thing, right? So that we are going to have a lot more this kind of smart building idea. Smart building concerned with smart, this kind of those components inside the building. While smart elevator, then in this case, you have a lot more this kind of interesting, this kind of connection to the internet for this thing, right? So in this case, once a lot more sensor, we can sense the kind of this activity, right, of this kind of elevator, and then in case there's some big, for example, big problem, some vibration, or some maybe the cable. This if it's too old, and then this cable may cause some problem, they break. So that if you have this kind of sensor to send this kind of vibration of this kind of elevator, and then provide this additional way, maybe also without sensor data, with all this AI, we can try to understand this kind of vibration of this kind of elevator, and then try to do this kind of predictive maintenance. So this become quite important and now, yeah. And okay, so that I don't know, do you have any question? Do you have any question for this chapter? So that at least we give you some quick review, overview about this kind of building system, right? Again, building system can be very, but in general was what? Mechanical engineering design for the building. Why? And then we water system. Why? And then we also electricity system. Why? And so that, and the lighting, so that and also communication and the fire engineering. So this is a typical those like engineering for building. Again, do we have any question or comment for this kind of a building, system? No problem. No question. Oh, okay. So that so we do have some student try to ask some little question about this kind of the issue for this thing. The one student asked, what is the sash? Why? Sash basically is a part which hold the glass now in position in that special frame within the window frame. Okay, so that the real window can be very complicated, right? So that what one student asked, let me show you. Sash is a part of this kind of window system. Right, doing that. Window is not simply a piece of glass. There's additional frame, right? So that Do you understand? So that's tell you that typically that's why there's a lot more terminology to show about the thing. Okay, so that we may just show you about this thing. Okay, so that let me quickly show again. Well, I think it's important for all of you to ask the question, right? So that if just listen and then without try to ask question or thinking, why maybe you will be you cannot really learn. Do you understand? So it's important to ask question. Yeah. And so one student also Jatin also asked about the quiz. I will ask the TA to at least try to arrange this kind of quiz for you. Do you understand? I think we already almost goes almost one month, right? So that it's important. You are not only just listen, right? At least try to do some study, and then I will ask the TA to provide the quiz on Canvas website so that you can try to do some study. Okay, so that one student also asked if I can see that one student asked the question about this arrangement for midterm and final exam. If some of you have to do this kind of compulsory testing during the exam or thing, well, I can see that I understand the Hong Kong government will require this kind of compulsory, this COVID-19 testing. I hope it will not have in conflict with this kind of exam, online exam, so that I think this kind of exam, online exam, will not be too long, because most likely we have a MC multiple choice question and very simple brief question, so that don't worry, I will not give you like a long 3 hour or many hours exam. So this is a general education course, so that I think that I please don't worry too much about this kind of exam. Most likely, probably you only spend maybe 30 minutes or less than 1 hour, right, for this kind of very simple MC multiple choice question, so that I don't think you should worry too much about this kind of exam. Of course, in case some student are required by the Hong Kong government to do the compulsory testing during the exam, so that please try to let the TA know, so that the TA will help to make some proper arrangement for those students if they really have problem due to this kind of the requirement from Hong Kong government to do this kind of compulsory testing for the COVID-19. I do understand, so that the number of new cases can keep increasing. Why 10,000 people, 20,000? I hope you will not get this virus, but also there's some additional requirement from Hong Kong government. So don't worry about this issue. Okay, so that but again, I still want to remind you about the thing. Why please do keep you healthy, and then make sure that you follow this kind of typical guideline from our guest lecture, so that this is something I just let you know about this thing, and of course if you do still do this kind of exercise every day, right, even in an apartment, or you from my experience, our UST campus should be much better. That this virus is airborne. UST campus has a much better this kind of air quality, so that ventilation and things, so that if you are able to come to the campus, and then I hope you can do more exercise to make sure improve your health, and then to make sure that you have less chance to get this kind of virus infection, COVID-19 virus infection. So that still, this is my suggestion for all of you. Again, I understand we have we are in a difficult period of time, so that I do hope that all of you can be very careful, right, and improve your health, and then so that of course I do think that this kind of thing, unfortunately, I don't think this number of new confirmed cases in Hong Kong would go down. I can see still continue to go up, unfortunately, so that we have a very high population density in Hong Kong, so that this is one of the big issue, right? So that even those MTR, those kind of step also got some bus or the truck driver and a bus driver, most likely you can easily get this kind of virus infection. I do think I hope that all of you be very careful about in this period of time, and then so that this is something we are in the very difficult situation. Yeah. So do you any question in this? Of course, I may give you additional information for you to think about this issue, right? Especially we do think this kind of air conditioning system for this kind of tall building will transmit this kind of virus. So what do you think? Do you think this kind of issue, so that I can see this is another issue I can provide additional information for you, right, to think about how to deal with this kind of COVID-19 if you are living in this kind of tall building, and then so that the some of virus may go through this kind of central air conditioning system. So that in this case, what do you think? This can be a big problem for all of you to, and then but unfortunately that's why I just share with you about if your family has this kind of risk, you may think about to buy this kind of special air purifier, right, which can kill this kind of virus, so that there's a multiple this kind of air purifier, right, can be used for the building or personal this application. So that this is something I do think is a quite important thing for all of you to think about. Okay, do you any question? If not, I think oh, we have a one more question. One student mentioned the exam open or book or closed book. So that I do think this is an important issue, but of course we will follow UST policy, right? Even it's online. So during the online exam, usually I just STA, right? For all of you during the online exam, you have to turn on the webcam, and then it's based on UST policy. You cannot try to use smartphone or connect to internet to see to do some Google thing, right? Of course, we have additional measure. I do some student concerns some possible cheating. Of course, through our Canvas this kind of exam, so that we Canvas have some way to shuffle this kind of sequence of exam, right? If you have 20 questions, and then every student have different arrangement. The sequence of question 1, 2, 3, 4 may be different from one student to another student. So this is another way our STA to use this kind of special feature of the Canvas. This thing, so that when you do this kind of work on the exam through the Canvas, so that you will this kind of question 1, 2, 3, 4 the sequence. Now the answer would be different from the other students' question, like 1, 2, 3. But eventually, once I think that Canvas do have this kind of way to minimize this kind of cheating problem. I just let you know that we try our to follow the UST policy, and do ask our TA to really prepare the proper this kind of question online question, and then yeah. One more student thing. Most likely we will try to give you this kind of simple MC question. Is much easier. But of course, we will try to again use the Canvas feature. Canvas has this feature to do randomize this kind of sequence of this exam, so that I can see this is at least this is one way to minimize the problem. Okay. Okay, if no other thing, probably we should still want to go to the next chapter, so that this is another chapter about this intelligent or smart building. Well, I think this is something I would say quite important, right? People talk about this kind of smart building, intelligent building, so that again, from my point of view, you have smartphone. Smartphone is why it's smart, because typically every new smartphone you have at least about 10 or 20 sensor, and the sensor and actuator, and also the some AI function. So that in the near future, I will see more building will be getting smarter with adding a lot more this kind of local sensor and AI. So that thing will be very important and useful. Okay, so for every building. Oh, one student also mentioned. Anyway, I will try to upload this kind of lecture note in probably 5 to 10 minutes. Don't worry. So that okay. So that anyway. So here this is something again. So that for every chapter we give you some brief introduction about what we cover, right? And then so that of course typically intelligent building or smart building, this idea is not new. Okay, I think it exists this for at least I would say at least 30 years, right? So that typically in the old day, right? So that maybe 30 years ago, when we look at intelligent building, we just still mention, okay, so this building will be controlled by some of the maybe computer or some special type of computer thing, right? Digital computer, right? And then gradually, of course, I think the kind of intelligent building or smart building and gradually evolve, right? So that and then so that I would say in the near future, a lot more this kind of building equipped with local sensor, essentially micro sensor. Micro sensor you use in your smartphone is your locals, right? And then additional AI. So this is something is quite important. And in general, when we talk about this kind of intelligent building, smart building, so that typically we hope we can try to improve this kind of building environment, and then of course lower down the costs, maybe energy efficiency, security, thermal comfort, and a lot more. Of course, now for this period of time, hopefully we have some smart building can really deal with this kind of COVID-19. That's another thing, right? So that typical buildings, we try to control temperature, humidity, right? And then lighting, and then so that in the near future, human thermal comfort, right? And a lot more security, yeah. And then typically, again, you see, this kind of idea of this kind of intelligent smart building is not new, right? So it first was actually coined in United States about in 1980, right? Almost 40 years ago. And gradually we have more automation in the building, right? And responsive building, effective building. But of course, now I can see in this particular period of time, I think we may try to think out in smart building or connected building, or even IoT building, right? So that now this is something, or maybe AIoT, right? With AI and IoT, so that technology, so that I can see now we have a lot more this kind of new technology, right? A lot more this kind of IoT sensor, AI, and the 5G and everything will be very useful, right? For this kind of smart building, intelligent building. Okay, so that typically again, so this something you can see again with can think, then we can think about now this intelligence, right? Or smart building will be gradually applied to different part of this kind of subsystem for the building. Why? You have smart fire engineering systems, security, smart lighting, smart energy system, smart HVAC, smart communication. So with additional thing, this is something I would say gradually you will evolve to this kind of smart building technology. And of course, in general, we have a lot more these things to study. So that I'll just show you. Typically, most likely will come from the BMS system, building management system, and then of course additional space management, business management system. So this is one of very common thing. Okay, I think we almost around the time today. So that again, I think again I will try to provide some additional this kind of answer to some question people ask from this Zoom chat. So do you have any question for today's lecture? I do understand so that if you really have problem, suffer about the COVID-19 problem, please do feel free to let me know. Of course, I do have some communication with my colleague, Professor Carson, and who are working on traditional Chinese medicine for more than 25 years. So that some of our this kind of PG student got this kind of viral infection. So that at least we have some expert TCM expert in our UST can provide some consultation for you or for some student or your family got this kind of COVID-19 virus infection. If you need help, please feel free to contact me, and then so that at least something, this is a very difficult period of time. Okay, so that if no more question, and then that's it for today's